Okay, good morning, everyone. Hi. How did the homework go? Any questions? Any questions? Yeah. Number 10, which section? 11.11. Okay, we look at that. So we have the function f of x equal arctangent x. And they want us to find the third degree Taylor polynomial at a equal to 1. Okay, so the third degree Taylor polynomial, we just always write the formula a equal to 1. It means we have to evaluate the function at 1. So this is a 1 here, plus the derivative times x minus 1, plus the second derivative over 2 factorial, so times x minus 1 square, plus finally the third derivative at 1 over 3 factorial x minus 1 to the power 3. So that's the third degree Taylor polynomial. So to be able to find it, I need basically to practice my differentiation again. So we will do that. So my original function is the arctangent. So at 1, it's arctangent of 1. And if you remember, it's pi over 4, because that's the angle whose tangent is 1. Now, f prime. Derivative here is 1 over 1 plus x squared. So in this problem, I have to use the formula because I don't know the Taylor series at 1. I know the Maclaurin at 0. So at 0, I can just pick up the book and pick it up from there. But because at 1, I have to do all the work. So f prime, so it's going to give me that f prime at 1 is 1 over 1 plus 1 squared. This is equal to a half. Now, the second derivative. Okay, so let us remember how we find the second derivative. Now, of course, we can use the quotient rule, or we can rewrite this as 1 plus x squared to the minus 1. And the derivative will become the power times 1 plus x squared to the minus 1 minus 2 times the derivative of the inside. So we're getting minus 2x, 1 plus x squared to the minus 2. And now I have to evaluate the second derivative at 1. So I'm plugging 1 in here. I will get minus 2 over, this is minus 2. So here I'm going to get 2 to the power 2, which is leaving me with minus a half. So the third derivative, and choose equal. All right, just differentiate. That's the product. So I have to use the product rule. And what does the product rule give me? Derivative of minus 2x, it's minus 2 times to the power minus 2 plus minus 2x times the derivative of this term, which is the power 1 plus x squared to the power minus 3 times the derivative of the inside, which is 2x. So it's a little bit messy, but we have to evaluate. So this is going to be, so we simplify it a little bit. We don't have to simplify it a lot because we're going to evaluate at 1. So we don't really have to simplify a lot. Minus, minus, this is going to give me a plus. 2 times 2 times 2, that's going to give me an 8. X times x, it's the x squared. 1 plus x squared to the minus 3. So now I need the third derivative at 1. Remember, we have to evaluate at the base point. So this will give me the following. So that the first term will be minus 2 over 1 plus 1, 2 square, plus 8 over 2 to the power 3, which is basically 8. So we will get minus a half plus 1, which leaves me with a half. Now we collect everything and we see what we got. So what is the third degree Taylor polynomial? It's equal to the value of the function at 1. The value of the function at 1 is pi over 4. So that's pi over 4 plus the value of the derivative at 1. So that will give me a half times x minus 1. Remember, that's the equation of the tangent line. That's really the equation of the tangent line. That's the first degree Taylor polynomial. Now we're going to add more. We're going to approximate it by a quadratic. So it's the second derivative at 1 over 2 factorial times x minus 1 squared. So I will pick up the second derivative, which is minus a half over 2 factorial times the quantity x minus 1 squared. So that's approximating the arctangent by a quadratic function. That's the parabola we will get. So that's approximation by a quadratic. Finally, we approximate it by a cubic. So I need the third derivative. But the third derivative is a half divided by 3 factorial, the quantity x minus 1 to the power 3. And the last step would be to simplify a tiny bit. Minus a half divided by 2 factorial, this will give me minus 1 over 4. And a half over 3 factorial will give me 1 over 12. So the final answer will involve the following. This will become minus 1 over 4. And this will become 1 over 2 times 3 factorial. 3 factorial is 6. 2 times 6 will give me 1 over 12. So it's really basically plugging in the formula. In this particular scenario, we have no way around that because it's at a equal to 1 and we don't know any Taylor series except, only the Taylor series at 0. Those we can use them. After that, we really don't know them, so we have to use the formula for the Taylor polynomial. Okay? Any other question before I move on? Very good. So today yesterday I talked about the circle, and we talked about what's the equation of the circle, and the equation of the circle, if this is a circle, okay, if the center is HK and the radius is R. So center and radius determine a circle. You don't need more information to find a circle. And the equation of the circle become x minus h squared plus y minus k squared equal to r squared. So that's a circle. And we derived it in the most natural way. We said, okay, if you have a circle, that's the center and that's the radius. What characterizes every point on the circle is that the distance from here to here is constant. Means the distance from here to here is r. That's what characterizes. Can you put the work on the screen? I missed the last slide. Okay, hurry up, Mendo. Yes, here you are. Okay. Very well. So we use the fact, we could use Pythagorean theorem to compute the distance from P to C, and then we said this is equal to r squared. Okay, now today we're gonna do the ellipse. So ellipse. Okay, thank you. All right, so the ellipse. So first, what is the ellipse geometrically? And then what's the formula for the ellipse? Geometrically, what is the ellipse? So first, geometrically. The circle geometrically are all the points which are at a constant distance from the center. That's geometrically what this is. What is the ellipse geometrically? Sorry. We start with 2 points, F1 and F2. 2 points. We fix 2 points. So we fix 2 points, F1 and F2. That we're going to call them foci. Okay, we fix them. So those are fixed. And we fix something else. We fix a number A positive. So those are the parameters we have. We have 2 fixed points, F1, and another fixed point, F2. And a number, A positive. Ellipse will be, that's the geometric definition. All the points that has the following property. The distance, the sum of the distance between the point and the foci, F1 and F2, is a constant number that is equal to A. To A, just so the formula will become easy. So what is an ellipse? You fix 2 points, and it's all, those are fixed. The number A is fixed. It's all the points in the plane that have the following property, and will be a lot of them. The sum of the distance, it means P F1, the distance from P to F1 plus the distance from P to F2 is a constant number. That's what geometrically is the ellipse. So if this point is on the ellipse, this would be the one symmetric to it, will be also on the ellipse. So geometrically, the ellipse is all the points that satisfy the condition that the sum of the distance has to be a fixed number. Now, we're going to derive the formula for the ellipse, but I would like to show you something. Probably most of you have seen that in high school, is how we really can construct an ellipse geometrically. Geometrically, the way we can construct it is the following. You fix the 2 points, and you take a string where the length of the string is 2A. So you take a string, and then you take it and basically you push it up and you start rotating the string. If you rotate it, you get the shape of an ellipse. So I'll show you something if it's gonna work out, I don't know. And it's a very easy way how to visualize the ellipse. So let me go to share screen right here. And so I will show you that a little bit. So that's the idea. Those 2 points are the foci. And the length of the string, this loose string, is the 2A. And now this guy is gonna draw the string. So watch how he's doing. So just go around. The length is not changing because it's the length of the string. And that's exactly how you get an ellipse geometrically. That's geometrically what's an ellipse. So every point on the ellipse, every point, the sum of the distance to those F1 and F2 is a constant number, which is the 2A. Okay, so that's really what an ellipse geometrically. But of course, the question for us is, how can we find the equation of the ellipse? What does it mean to find the equation? It means that you take a point that satisfies this condition, and you ask yourself, what is the relationship between the X and Y coordinate? So if a point does satisfy this equation, so X and Y are related by an equation. What is the equation that relates them? That's what it means, finding the equation of the ellipse. Finding what's the equation that relate the coordinate of every point on the ellipse. So I will not go through all the details, but I will definitely start us up a little bit so you know where things come from. So here we are. Okay, here we are. So I have the point P of X, Y. And what characterizes this point is that the sum of the distance should be equal to 2A. Now, what's the distance from the point P to F1? And what's the distance from the point P to F2? To be able to derive this equation, we're going to do the following. We are going to put the foci on the x-axis. And we're going to put them in the following way. We're going to put them on the x-axis so that 0 will be at the center. So I will call this F2, and I will call this distance, let us say C. So that's how we're going to put those points. And so this will become C0, and this point will become minus C0. F1, F2 has a name, and they're called the foci. That's what they are. And then I'm going to pick a point, P of xy. So I'm going to put the foci on the x-axis so I can really work with the problem. Otherwise, we cannot really find an equation. I'm going to take a particular point, P of xy, such that the sum of those is a fixed number. We're going to call it 2a. The 2 needed to make the formula simple. That's why it's 2a, not a. So how are we going to derive? We're going to start with this. That's what characterizes a point. And try to use that to find the equation. So as I said, I will start it off. What's P of F1? What's the PF1? It's the length from here to here. But what's the length from here to here? It means what's the distance between 2 points? So let us remember the distance formula back from whatever you studied that. If you have 2 points, A and B, any 2 points in the plane. So A is x1, y1, B, x2, y2. So what is the length of the line segment AB? Again, Pythagorean theorem tells me the distance is the change in x squared plus the change in y squared. That's the distance between any 2 points. So I'm going to use this verbatim in here. What's the distance between P and F1? It's the square root of the change in x, x plus c squared, plus the change in y, y minus 0, y squared, plus. The distance between P and F2 is the following. Okay, x minus c squared plus the distance y squared. So if a point satisfies the equation, to satisfy the idea that the sum of its distance to the both foci is a constant number, it means that's the equation that's going to exist between x and y. What's given is c, so we know where foci are, and what's given is a. And we have to find the relation between them. Now, of course, this is a mess. We can never really work with that. So we're going to manipulate this algebraically. And that's where the book has it very clear. I will get you started on it, but then I will write the formula. So the idea would be, that's the idea of the book, because we have square root and want to really get rid of them. And then we moved it this way. And then we need to get rid of the square root. How we are going to do that? We square this, and we square this term. And we will be collecting like term. So it's a little bit of algebra, not deeper than that. We collect like term, and then we get to the following formula. So we do algebra, simple algebra, nothing really deeper than that. We do simple algebra, and then we will end up with the following equation that will relate the x and y component of the point P. So that's what related. And the equation would look like that. X squared over a squared, probably a lot of you are familiar with it, equal to 1. Very good. The A is the A. This A right there. What is the B? What's given usually for the ellipse? What characterizes the ellipse is the 2 foci and the point here, the sum of the distance. So where is this B coming from? The B coming from manipulating this formula algebraically. And the B, once we manipulate it, is going to be equal to a squared minus c squared. That's where the B is coming from. So, and that would be the equation of the ellipse. Now I'm going to take this equation again. And we're going a little bit analyze it so we can internalize it and it become easy for us. So where the equation comes from is not coming out of nowhere. The equation exactly coming out of this geometric interpretation of the ellipse, which is actually kind of nice interpretation. That's where it's coming from. By manipulating that, we get to an equation that looks like this. Now I'm going to analyze a little bit this equation before we start working with it. So let me analyze it a little bit. And what do I mean by analyzing it? It means how it's going to a little bit look like. So we will analyze this equation. Okay, so it's x squared over a squared plus y squared over b squared equal to 1. And the relationship between where this b coming from, the formula will tell me it's a squared minus c squared, but I'm going to rewrite it as c squared equal. So I'm going to bring the c squared this side, a squared minus b squared. And for a reason that it's easy to memorize it this way. Very good. Now let me ask you a question. Which is bigger? Go back to the picture. 2a is the sum. Which is bigger? Is a bigger than c or a less than c? 1 or 2? Use your geometric intuition. Which has to be bigger, a or c?
The hypotenuse.
There is no hypotenuse because there is no right triangle. Doesn't have to be.
Okay.
Okay, so I can take this point here.
Right, right.
There's no need for hypotenuse. Which one do you think? Think about the string to be able to draw this. C is from the center to one of the foci. It means the whole here is 2C. And the sum of those is 2A. So which one? Definitely 1A has to be bigger than C.
Mm-hmm.
You cannot really build the string. So if it's 2A is less, how are you gonna go around? No way. And another reason is that in a triangle, then the sum of two sides of a triangle is always larger than the third side. So if you take any triangle, the sum of any two sides have to be larger than the third. And that's really another geometric interpretation. So A is always larger than C. And that's so the point. So now let us go back to analyzing this equation. Step number 1. In this particular equation, that was my scenario. My foci were here and here. That's where my foci were. This is F1 and that is F2. This is the foci, that's all I know. In this equation, if we realize which is going to be bigger, this is positive. It means a squared has to be bigger than b squared. So in this equation, my a has to be bigger than b. 2. What is the x-intercept? So this analysis will help us draw ellipses very easily. We know how the equation looks like, but now we have to draw them. What's the x-intercept? How do we find the x-intercept? Quickly. So it means where does the ellipse intersect the x-axis? So we set y equal to 0 and we figure it out. If y equal to 0, I will have x squared over a squared equal to 1. It means x squared is a squared. X is plus or minus a. So this tells me that the intercept occurred at plus or minus a. This is C. A is larger than C. So plus a and minus a. These are the intercept. Now, what are the y-intercept? What are the y-intercept? Okay, 3. What are the y-intercept? 3. Y-intercept. To find the y-intercept, we're going to set x equal to 0. It means y squared over b squared equal to 1. which is gonna give me y equal plus or minus b. And in this scenario, the formula tells me that a squared minus b squared, c squared is going to be this quantity. It means it's going to force a to be larger than b. Otherwise, c squared will not make sense. So b in this scenario is definitely the smaller one. So how will this affect the graph? It means my b is going to be right there. So my ellipse is going to be, so from here to here, these are the intercept, that's the b. And from here to here, that's the A of the formula. So the graph is going to look like that. That's the graph of my ellipse. Okay, so if I have ellipse, x squared over a squared plus y squared over b squared equal to 1. So the b is the distance from the center to here. The a is the distance from here to this endpoint right there. Now, some names, some notation. Those two are called the vertices of the ellipse. Okay, so the vertices of the ellipse, we don't call those 2 points as the vertices. The vertices of the ellipse are this point and that point. The ones really which are aligned with the foci. Those are the vertices. And then this axis, which is the x-axis, we give it a name and we call it the major axis. And this one is usually called the minor axis. So before we take a very straightforward example, part 2 would be the following. What if we put the foci on the y-axis? How will the picture change? So my idea now is the following. The foci are going to be here. Sorry. The foci are on the y-axis. And so this is F1 and F2. And the ellipse is all the points. So sum of the distance to those is actually a constant number. What's going to happen here is you're going to get an ellipse. But instead of being wide horizontally, it's going to be wide vertically like this. That's really the difference. But how is the formula affected? Actually, nothing much. If the foci on the y-axis, the formula will be exactly the same because we can derive it almost in the same way. But the difference, so I'm not going to change the way the formula looks, but what I'm going to change is, in this case, the b will be larger than the a because it's going to be flat or vertically. And the c squared will be the larger value minus a squared. So if you have the foci on the y-axis, the equation will be basically the same. That's why I didn't change anything. But the b will be larger than the a. It means the b squared under the y squared will be larger than the a. And c squared will be b squared minus a squared. So that's the equation of the ellipse. So we're going to do one problem, which is basically straightforward at this stage. So suppose I tell you the following. Okay, I give you the following equation. I will just x squared over 4 plus y squared over, let us say, 16 equal to 1. Now, what you should start basically almost recognizing that this is represent the equation of the ellipse. So x squared over a squared plus y squared over 16 equal to 1. That's how the ellipse looks like. And the question is, find the foci and the vertices. So vertices and the foci. Okay, so how do we handle those type of problems? Step number 1, the way we see them is we have to know whether the foci lies on the y or the x-axis. And what determines this is which one of those is larger. So in this case, my a is 2. That's the a. My b is 4. So if b greater than a, it means that's the scenario where the foci is on the y-axis. Okay, so that's the first thing we noticed. And now, what are the vertices and what are the foci? All right, so I usually like to draw because I can visualize things easily. That's my view right here. So the vertices are gonna be right there. Everything's on the y-axis. So what are the vertices? The vertices are given by b. So b squared is 16. B is equal to 4. So these are the vertices. So the vertices would be 0, 4, 0, minus 4. This is really is my B in the picture. So the vertices will be 0, plus, or minus 4. The A is here now. The A is 2. So this is this kind of ellipse. This is the B, and this is your A. The foci are on the y-axis in this scenario. So what are the foci? Now, foci. C squared is the largest between B squared minus A squared. Now, my B squared here was 16, right there. And my A squared is 4, which is 12. It means my C is square root of 12 or 2 square root of 3. Means from here to here, that's the 2 square root of 3. So my foci are going to be 0, because we are on the y-coordinate, plus or minus the square root of 3. So we have basically 2 foci, one as 2 square root of 3, and the second is the minus 2 square root of 3. Now in this scenario, the y-axis is become the major axis. And the x-axis, we call it the minor axis. Okay, so that's the equation of the ellipse. It's definitely slightly different than the circle. And we have basically to start recognizing it the minute we see it, because they play, of course, an important role in your learning. What is the equation of the ellipse? All right. I think I have to stop right here. Next time, it means on Monday, we're going to shift the ellipse and we're going to talk about hyperbola. All right. Any questions? Okay. Good luck on your quiz. And if you have any questions on the quiz, I will be basically stay with you. It means if you have questions, you can use your chat privately to ask me questions. All right. Good luck. Get going.